Okay, so let's start walking through our quote-unquote 4 steps, which we know, depending on how we want to count it now, is 4, 5, 6 steps. But before we get into the actual steps, we know the first thing we've got to do is our preparation stage. And I've already listed here everything we already know to prep from the previous chapter. We still need all these things. We still need to know the value of K. We still need to know the number of scores in each treatment condition. So remember, if there's 3 treatment conditions, there'll be 3 little n's. The total number of scores for the entire study. The treatment total for each treatment condition, the summation of raw scores for each treatment. The grand total, the summation of raw scores for the entire study. Sums of squares for each treatment condition, so you'll have 3 of these as well. And the overall square every raw score in the whole study and sum it all up. All of these things we had to have last chapter. Again, we're mostly doing the same calculations, same formulas. So we need all of those things to get that done. In addition, we've got one new symbol. A capital P. We know a lowercase p means proportion or probability, depending on what we're writing. Capital P. So capital T is treatment total. Add up all the raw scores for a treatment condition. Capital P is a person total. It's the personal total for an individual. So to get a p-value, add up all the raw scores for an individual person. So Tom's raw score in condition 1 plus Tom's raw score in condition 2 plus Tom's raw score in condition 3, that would be Tom's personal total. So the way the data is often set up, your treatment totals, you're usually adding down the column. So it's treatment condition 1 and everybody's raw scores, and you add it all up and you get the treatment total. Excuse me. Personal total, we tend to add across from side to side, add across the row. So again, this person's first score plus the same person's second score plus the same person's third score, we add across, we tend to get a person total or personal total. So there's only just one extra thing. So think about what that means though. If you've got 3 treatment conditions, you'll have 3 treatment totals. If you had 4 treatment conditions, you'll have 4 treatment totals. So you're really usually going to have 3 or 4 of those. You have a p-value for every individual who participates in the study. So if you have 10 people in your sample, you will have 10 p-values to compute. If you were doing a real-world study with more like 100 individuals in it, you would have 100 p-values. Every individual person gets their own little subtotal of all their personal scores across the entire study. The only other thing that I listed as prep work before is to write out your results table. So again, this is our formula sheet. So this is the one we used from the last chapter. Again, this is next chapter. Here's our formula sheet for this particular chapter. So make sure you get your handout out, pause it if you need to go find it. And you'll see that it's the first, second, and last rows are all the same, but we've got 2 extra rows because we need a row to calculate the individual differences and then a row for when we subtract it out. So you'll notice that what's grayed out over here is a little bit different. Our total mean of squares, our total variance is grayed out just like it always was. Again, because we don't need it. It doesn't help us actually calculate anything. But notice our mean of squares or variance for error, which was within treatments, is grayed out because that's not what we're using for error anymore. We're using the thing labeled error for error now. So we just move that box down a little bit. So again, you could build this when you get to step 3, or you could outline it in advance and prep work, however you really want to do it. But that is our stage 1 preparations, or prep stage. Then we can go to stage 1 or step 1. As I mentioned to you in the last chapter, this step is 100% identical as the last chapter. So our alternate hypothesis is, just like last chapter, at least one of our treated population means will be different from another treated population mean. Again, very generically stated, it saves us having to write out 4 different hypotheses. And for our null hypothesis, we know that's treated population mean 1 will be the same as treated population mean 2, which is going to equal, of course, treated population mean 3. So again, it's an ANOVA. There are no negative F ratios or F statistics. Everything's one-tailed. So this is the one and only way to do step 1 for either of these chapters. So we're going to move forward into the next steps in the next video clip.